Math 1, Practice 4.2.4, Fitting Functions to Data. So, we've got a table here, time studied in hours for our students, score earned on the test. So we want to create a scatter plot, describe the shape, draw the line to estimate, we'll use the calculator to estimate it, and find the equation that estimates the relationship between the hours studied and the score earned. So, we go to the calculator. So, we use list and spreadsheet, take the stuff from the table, type it in, then we go to our data and statistics, choose the variable for time, for score, as we named them, and then we can see our scatter plot, okay? Then it wants us to find that line of best fit, so I hit Menu, go to Analyze, okay, go down to Regression, and then I have all the different types of regressions. The main ones we're using is linear, though sometimes we could use exponential as well. Okay, then we hit that, and we get our line of best fit right there with the equation y equals 12.3616x plus 30.8038. Now you could round out to 12.4x plus 30.8. That's fine. I probably wouldn't round further. 12.4x plus 30.8. Okay? So we saw the shape of our data as well. Alright, so let's do it this time. So, store manager conducts research, trying to see if there's a relationship between the number of items tried on and the number of items purchased. So we create a scatter plot, describe its shape, and then decide, can we use a linear equation to figure it out? So once again, we create our list and spreadsheet, data and statistics. Now we got a grouping here and a grouping up here. So it doesn't look like a linear equation is really going to work here, does it? Okay. But let's try it anyway. Go Menu, Analyze, Regression line. Let's try linear. Let's see what we get. So I hit linear, and we get that line right there above that, and then that equation. Then if we go Menu, Analyze, go to Residuals, we can click on Show Residual Plot, and that'll help us determine, was that a good line of best fit, and we look for randomness. Now, there's a grouping here and a grouping here, so that tells me that this is not the best. There's not really a relationship here. Our data is too scattered and too clumped together to really make it useful. Okay, so now let's take a look, years of schooling versus income in dollars. Let's see, scatter plot. Is there an equation that can show a relationship there? I did all the work already on this one, so here on this tab is my spreadsheet of the table, then data and statistics, and then I went Menu, Analyze, Regression, Linear Regression, and we see that this has a pretty close clump together, going positive, linear regression, and there's my equation, y equals 8,317.5 times x plus a negative 69,894.3. So that would be an equation we could use to then map that if we wanted to find out specific data for a year. Okay, so when we've got that calculator to do all the hard work for us, makes the rest of it pretty easy, isn't it? Okay, then we just have to understand how to look at it. So the year and the cost of lunch in dollars, let's see what kind of scatter plot we get, a line of best fit, and the equation. So once again, we use the calculator to do all that, and once we've got that entered into the calculator for the lists and spreadsheets, and then the data and statistics, and we choose from the list and spreadsheet, create the scatter plot, then we go Menu, Analyze, Regression, and Linear, and this is what we end up with. Now this one looks like almost a straight line, doesn't it? Okay, so pretty straight line, close together, and the equation we get is 0.114x plus 0.972 for the cost of lunch, which seems to keep going up and up and up. And there we go, guys.